Hello and welcome. We are now starting with the AWS Services introduction, as I mentioned in my first video, beginning with AWS SQS. I was thinking to create a beginner's guide covering the basics, and once I've done that for all the services, I'll do an advanced one. Let's jump into today's presentation. Here you can see the different topics I want to cover for the basic service introduction. Let's start with the overview so we understand what SQS is. SQS is a fully managed queue service. Fully managed means that AWS takes care of all heavy lifting. Remember the AWS shared responsibility model from my fundamentals video? Depending on the service you choose, you have either less responsibilities or more. SQS is a serverless service with best practices baked in. If you're not familiar with queues as a concept in general IT, it's not different than a queue in a grocery store, for example. It serves the same purpose of not overwhelming the cashier and keeping the order of first person in the queue is handled first as well. This is also called the FIFO principle, which stands for first in, first out. You can send and receive messages from SQS queues at any volume, while the service ensures that your messages are not lost due to hardware failures. You can store your messages for up to 14 days in a queue. You use queues to decouple components, systems, and create a more resilient architecture that scales. Just to mention it, SQS offers two types of queues, a standard one and a FIFO queue. I'm not going to dive deep into the differences in this beginner's video, but for now it's enough to know that in a FIFO queue the order of messages is always ensured. Also important are the keywords push and pull. Queues are pull-based, meaning that you have to actively check if there is a new message in the queue. In one of the upcoming videos, we will also cover the Simple Notification Service, in short SNS, which is a push-based service where messages are delivered to a target. You should always be aware what the pros and cons are from an architecture perspective when choosing services and underlying concepts. Now you should have a good understanding of what the SQS service is. Next, let's go a little bit deeper and look at the core concepts and features. We have producers that write messages and send it to the queue, and we have consumers that read messages they pick from the queue. So there could be one or many producers and one or many consumers for a single queue. Important to understand is that one single message in the queue can only be read and picked by one single consumer. So there is a one-to-one relationship and one message is not spread across the consumers. Here I've listed the most important features and things to know about SQS. You can have an unlimited number, yes, you heard right, unlimited number of queues and messages in those queues. It's not me saying this, but the official AWS documentation. What this really means is that there are no boundaries or architectural limitations that would limit the number of queues or messages. SQS supports payloads of up to 256 kilobytes. If you're not familiar with the term payload, it simply means the message content. For larger messages, you can use the SQS Extended Client Library, which essentially uses the Simple Storage Service, in short S3, to store the content, and it then stores the reference in SQS. SQS supports batch operations. A batch is a way to group multiple messages and then send or receive them at once, instead of one at a time. This is efficient and improves the performance of your application. With long polling, you are able to minimize cost as you have to do less API calls while receiving new messages as quickly as possible. When your queue is empty, long poll requests wait up to 20 seconds for the next message to arrive. When a message arrives, it's immediately returned, or after 20 seconds you get the empty response. You can send as many messages as you want to the queue while simultaneously read messages. In order to ensure a message is not processed more than once, it gets logged when it's received by a consumer. If the processing fails, the log will expire and the message will be available again. A dead letter queue, in short DLQ, handles messages that consumer has not successfully processed. When a message's maximum receive count is exceeded, SQS moves the message to the DLQ associated with the original queue. You can inspect messages in the DLQ to understand why your consumer has not successfully received them. Once you have remediated the issues, you can move the message back to the original queue. I already mentioned in the overview that you can keep messages for up to 14 days in a queue. Now I just want to emphasize that this really shows you what decoupling systems using SQS means. So you could run your consumer anytime within 2 weeks to process the messages. Now that we have understood what SQS is and with what feature it comes, let's have a look at different use cases to further deepen our understanding. You can use SQS to increase your application's reliability. It allows you to deliver large volumes of data without losing messages or needing other services to be available. You can use it to decouple microservices. Microservices are a way to build software where each part of an application is developed and deployed independently. For example, you could separate your front-end from back-end systems. Let's think of a banking application where customers immediately get a response in their user interface, but the bill payments are processed in the background. You are able to utilize SQS for event-driven architectures, in short called EDA. It is a design pattern where the flow of the program is determined by events such as user actions, sensor outputs, or messages from other programs. The use of SQS allows you to be more cost efficient by dynamically scaling your consumers based on the amount of messages that need to be processed. You don't need to have idle resources provisioned that are waiting for some work. These were just my favorite use cases, the ones I've used SQS for myself over the years. We quickly went through some of my favorite use cases for SQS, underlying the versatile way of utilizing this service. Now let's have a look at the last topic, pricing. It is really important to know and understand how and what costs are incurred in any of your architectures and solutions. In the fundamentals video, I already covered the expense advantage of AWS and cloud computing, mentioning that it is one of the most significant ones for me. We only pay for the resources we use and how much we use them, so no upfront costs are involved. Even greater, AWS offers a free tier for lots of its services, including SQS. Every customer can make 1 million SQS requests for free each month. The actual pricing and costs for AWS services depend on the region you choose for deployment. It's of course completely transparent and you can look up the rates. I'll add a link into the description. On the 2 screenshots below, you can see that I selected the Frankfurt region in Europe. As I mentioned, you can see that the first million requests are free. Between 1 million and 100 billion requests a month, you would get charged 40 cents per million requests for standard queues and 50 cents for FIFO queues. You get a discount if you are using the service more heavily, as you can see. Also important to know is that next to the API call request fee, data transfer costs are billed separately. Any data transfer into AWS is completely free. For data out of AWS, you can see the examples for the Frankfurt region, mentioning that the first 10 terabytes a month incur 9 cents per gigabyte. With that, we have completed the basic introduction to SQS. Let me know in the comment section if you have any questions or just share your thoughts and ideas for future content. If this video was valuable, consider to leave a like for the algorithm. Subscribe if you haven't already so you don't miss any future video. See you in the next. Bye.